pretty involved two-dimensional motion question, which is not perfectly parabolic. We take the approach of diagramming the fact that we have a y-up section of our motion, a y-down section of our motion, and a horizontal section of our motion. First, I have to figure out our relative velocities, doing a little bit of trig. Our horizontal velocity is 84.2 meters per second. And our vertical velocity is going to be, our initial vertical velocity is 70.7 meters per second. So filling out first the vertical components of our motion, initial velocity, positive 70.7. Final velocity, we will come to rest at the top of that arc, and we feel a steady acceleration due to gravity. What we need to solve for is the time required to reach the top of the arc, as well as how high we travel there. Employing proper kinematics, we'll first solve for, let's say, distance, using root kinematic equation Vf squared is equal to Vi squared plus 2AD. Plugged in, 0 is equal to 70.7 squared plus 2 negative 10, and D is going to be what we're solving for. All that appropriately, we land on a D value of 250 meters. Okay, and then for time, we would use the appropriate, I'm going to use the kinematic equation, Vf is equal to Vi plus AT. Plugging in for that, still coming to rest at the top of the arc, our initial velocity for being launched. Okay, time is going to be 7.07 seconds. What's known about y down is we begin our motion from rest. And our acceleration due to gravity is still constant. Okay, what isn't immediately apparent is how far we travel down to get back to the ground. Since we traveled up a distance of 250 meters, and that we have an 80-meter point of elevation from the beginning of our problem, we know that we'll end up traveling a total negative distance of 330 meters. Now we have three variables. We can use appropriate kinematics to solve for the remaining two variables on y down. I'm going to do that real quick. First, solving for time. T is equal to 8.12 seconds. Next, solving for the final velocity upon striking the ground. I will use final velocity squared is equal to Vi squared plus 2AD. VF is equal to negative 81.2. Turning our attention to the x components of motion, the horizontal components of motion, we have solved for our initial velocity upon launch. Now it's going to be a steady velocity since it's in the horizontal direction. Our time we can now solve for because we can sum up our other two time values. Since we take 7.07 seconds to travel upwards and we require 8.12 seconds to travel downwards, we complete our parabolic motion in 15.2 seconds. Now you can solve for the total distance traveled by employing a DST triangle. Total distance traveled is equal to S times T. Total distance traveled in the x direction equal to 1,280 meters. Now you can solve for any other sort of questions that are asked about that particular problem. What amount of time does it stay in the air? Well, it stays in the air for 15.2 seconds. How high does it travel? Well, including the 80-meter head start, it reaches an appropriate height of 330 meters. How far from the edge of the cliff is it fired? Well, since our total distance is 1,280 meters, and we've traveled 1,000 meters from the edge of the cliff, we are placed 280 meters from the edge of the cliff.